Slide 1. Today we delve into the CPO supply chain war. Broadcom versus NVIDIA. As the computational power of generative AI explodes, data centers are facing a physical limit. It is the I/O wall, the traffic jam at the entrance and exit of data. No matter how fast the chip processes, the copper wiring transporting data becomes a bottleneck, limiting the performance of the entire system. The only solution to break this wall is CPO co-packaged optics, a technology that fuses electricity and light inside the chip package. Leading this massive technological shift are two giants, Broadcom and NVIDIA. However, their approaches are as different as oil and water. Broadcom advocates for openness, aiming to create industry standards. NVIDIA pushes for integration, building a proprietary empire. Each strategy creates a completely different supply chain and completely different winners. Taiwan's Foki and Himax, America's Corning, and Japan's Ibiden. We will spend the next 10 minutes uncovering the choke points, hidden deep within the supply chain that investors must watch. Slide 2. Broadcom's strategy. The Tomahawk standard. First, let's look at the strategy of the merchant silicon giant, Broadcom. Their strategy can be summed up in one phrase: open alliance. Broadcom provides its switch chips to numerous hardware manufacturers like Dell, Arista, and Supermicro, creating an environment where they can freely build systems. The core of this is their flagship switch chip brand, the Tomahawk series. Currently, the mass-produced system equipped with CPO is called Bailey, which is based on the Tomahawk 5 chip. And the next generation system, being prepared for 2026, is Davison, or Tomahawk 6. Their aim is clear: democratization of CPO, spreading CPO technology, not just to specialized supercomputers, but to corporate data centers worldwide. That is why they prefer using interchangeable standard parts over proprietary specifications. For investors, investing in Broadcom means investing in the expansion of the entire market pie, rather than the win or loss of a specific company. Slide 3. Broadcom's supply chain, the glass giants. The supply chain supporting the Broadcom camp is truly an alliance of proven global giants. Their biggest partner is the American glass giant, Corning. Why Corning? It is due to technical reasons. Broadcom's CPO adopts a method called edge coupling, where optical fibers are connected horizontally from the side of the chip. This method is structurally simple and highly reliable, but it requires extremely precise glass blocks, or fiber array units, to perfectly align the optical fiber with the chip's cross-section. Corning is the world leader in this ultra-precision glass processing. Furthermore, for optical connectors linking the system to the outside, they employ companies leading industry standardization, such as Japan's Senko and America's TE Connectivity, and the final assembly of the switch box is handled by the Taiwanese power supply giant, Delta Electronics. In this way, the Broadcom camp is characterized by a horizontal division of labor, where top players in each field support one another. The strategy is not for one company to monopolize, but for everyone to expand the market together. Slide 4. NVIDIA's strategy. The COOP Fortress. In contrast, NVIDIA's strategy is the opposite. Their keyword is total vertical integration. They sell not just the chip, but the entire rack as one massive AI factory. There is no room for third-party products to enter, nor is there a need to conform to standards. Performance is everything. At the heart of this strategy is optical engine technology. NVIDIA has adopted a technology called COOP, Compact Universal Photonic Engine, developed by their manufacturing partner TSMC. This is an extremely difficult technology that uses TSMC's 3D stacking expertise to build optical circuits directly on top of electronic circuits. By fully utilizing this best-in-class technology from TSMC, NVIDIA aims to maximize NVLink performance and build a fortress that competitors cannot follow. Slide 5. NVIDIA's supply chain. The Taiwan lock-in. Supporting this fortress is a surprisingly narrow, yet deep lock-in to the Taiwan ecosystem. The manufacturing anchor is naturally TSMC, but investors should pay attention to two hidden monopolies surrounding it. First is Taiwan's Foki. Why Foki? It is a question of heat. NVIDIA chips get extremely hot during manufacturing. Ordinary adhesives and connectors would melt. Foki possesses a proprietary patented technology called Relfacon. This stands for Reflowable Lensed Fiber Array Connector, and it is said to be the only solution currently capable of withstanding the high-temperature processes of semiconductor manufacturing. For NVIDIA's CPO, Foki is irreplaceable. Second is Himax. Known for display technology, they actually make micro-lens arrays. MLA, clusters of microscopic lenses. These parts, which expand the light beam from the chip to facilitate connection, are also seen as being exclusively supplied for TSMC's CPO. NVIDIA's spectacular AI revolution is actually supported by these small to medium-sized Taiwanese companies. Slide 6. Technical divergence. The battle of coupling methods. Why are the suppliers so different? Let's dig deeper into the technology. It is because the physical approach to how to connect light is fundamentally different. Broadcom chose edge coupling, passing light from the side edge of the chip. This is an extension of existing technology and a low-risk choice. That is why they need Corning with its high-precision glass processing. On the other hand, NVIDIA chose vertical coupling, grating couplers, passing light from the top surface of the chip. This allows using the entire chip area for overwhelming density, but alignment is fiercely difficult. That is why they need the set of TSMC's ultra-fine processing capability, Himax's micro lenses to control light angles, and Fosai's connectors to withstand heat. This difference in technical choice directly determines the winning stocks. Slide 7. The shared battleground, substrate revolution. However, there is a massive challenge both companies face in common. That is the substrate revolution, how to transport light out of the chip. With current technology, hundreds of hair-thin optical fibers are connected to the chip. But this results in a spaghetti mess, which is the biggest factor driving up manufacturing costs. So, the movement is to embed light paths, waveguides inside the substrate from the beginning. Here, Japanese companies show overwhelming presence. Shinko Electric Industries leads the world in developing polymer optical waveguides, using Nissan Chemicals materials. If the substrate carries light as well as electricity, the hassle of fiber wiring is drastically reduced. Also, Ibiden is leading with flatter and more rigid glass core substrates. Glass is an ideal material for transmitting light and is essential for next-generation CPO. Whether the Broadcom camp or the NVIDIA camp wins, Japanese substrate technology is required for cutting-edge packaging. This can be called a safe zone, where you can bet on the whole field. Slide 8. The laser paradox, ELS, standardization. Another commonality is the laser source. Semiconductor lasers are extremely sensitive to heat, so they cannot be placed next to a GPU emitting nearly 1,000 watts. They would break immediately. Therefore, the industry has unified on a method where the laser is separated from the chip and placed as an external ELS, external laser source, on the front of the box. The suppliers providing these ELS modules are America's Lumentum and Coherent. They are the winners of omnidirectional diplomacy, supplying lasers to both Broadcom and NVIDIA. The more AI data centers increase, the more their laser modules will continue to be needed, almost like consumables. Slide 9, 2026 Market Dynamics Value Shift. In 2026, the full-scale adoption of CPO will dramatically change the money, flow, and value chain of the semiconductor industry. Manufacturers who used to assemble finished optical transceiver modules may see that value added, absorbed into the chip package, and find themselves in a difficult position. The new source of value shifts from assemblers to front-end, middle-end processes. TSMC undertaking all packaging, Fosai and Himax making micro-optical parts, and Shinko Electric Industries and Ibiden making advanced substrates that carry light. This is a structural shift from assembly industry to semiconductor process industry. Investors must not miss this change. Slide 10. Conclusion. Identify the choke points. In conclusion, in this CPO war, which camp should you bet on? If you bet on the Broadcom camp of adoption and standardization, look at Corning supporting it and Senko for connectors. If you bet on the NVIDIA camp of peak performance and monopoly, look at Fosai and Himax complementing TSMC's technology. And safe bets, regardless of who wins, are Lumentum for lasers and Shinko Ibiden for substrates. Act 2 of the AI semiconductor boom is shifting from chip performance competition to physical connectivity competition. Look not just at the surface brand names, but at the companies holding the choke points, connecting light and electricity behind the scenes. That is where the hints for the next 10-bagger might be hidden.